3.4 is about complex numbers. This section is fairly short. The operations are fairly simple. So in this box, I just wrote the two things you need to know. A plus bi is the form of a complex number. A and b are real numbers, and I is your imaginary, and I squared is equal to -1. So last year in Algebra 2, you did work with some complex numbers. So the word complex is a better word than imaginary. So imaginary is not exactly what they are. It's just a word that the mathematician Cardano made up because they couldn't think of anything else. So they're not imaginary. They're just not numbers that we can see on an X and Y graph. You have to use a different plane. So let's go ahead. Let's just use these. And so a lot of this is just operations on imaginary numbers. So let's go here. Let's simplify this. That's what this should say. Okay, simplify this. 3 plus 2i minus 3i plus 2. So we just work with I as though it's a variable until we have an x squared, or an I squared. So this would be 3 plus 2i minus 3i minus 2. Combine our terms, so we get 3 minus 2 is 1. 2i minus 3i is -i. So that would be a simplification. So we're just treating it like a variable. We didn't have the I squared in that one, so it doesn't, we don't have to work with that. So that was pretty easy. Let's do this one. 4 plus 3i times 6 plus 7i. Distribute. So 24 plus 28i plus 18i plus 21i squared. So that's something we'll have to work with. Combine your i's. So you have 24 plus 46i plus 21i squared. Actually, I'm going to back up. I squared is -1, so that's 21 times -1. And so this would just be 3 plus 46i. That's our result. So again, treat I like a variable until you see I squared, and then it's a -1. Okay, so dividing these means most of the time we're just multiplying by a conjugate, which we'll talk about. So 7 plus 2i divided by 3 plus 4i. What you want to do is multiply by the conjugate of the denominator. So I'll multiply by 3 minus 4i, and I'll do that to the numerator as well. Okay, so I know that if we use the conjugate, it's going to create a difference of squares. So that will square the I. So I'll go through this one, making the distribution. But in the denominator, that's really just going to be 9 minus 3 squared minus 4i squared. We don't have to go through the whole FOIL or whatever you use to multiply binomials. But in the numerator, we do. So this would be 21 minus 28i plus 6i minus 8i squared. In the denominator, that's just like multiplying x plus 1 times x minus 1. It's x squared minus 1. So this would just be 9 minus 16i squared. Now we just combine our terms. So in the numerator, this would be 21 plus 8, because I squared is going to make that -8 positive. So that would be 29, and then minus 22i. And in the denominator, I squared is going to be a -1, so that's really 9 plus 16, or 25. And most of these problems want you to write them in the form of a plus bi, so this one would be 29 over 25 minus 22i over 25. And so that is a plus bi. for a second, yeah. Okay, so square roots. When you look at square roots, the square root of -1 is I. So when we are talking about imaginary numbers, complex numbers, these are generated from taking the square root of negative numbers. So if you have -1, square root of -1 is I, well, let's apply that to a couple of different things. What about if we have the square root of -4? Well, we take the square root of 4, which is 2, but we're going to have an I attached to it. Okay. So any number like that, if you have the square root of -9, it's going to be 3i. Here's a property that does not hold in this for imaginary numbers. Normally, we can multiply radicals together. Like, if this were √3 times √2, we could say that's √6. But root -3 times root -2 does not equal -3 times -2 or √6. So these are not equals. So with complex numbers, you cannot multiply radicals together like that. All right, so let's look at an example. √12 minus √3 times 3 plus root -4. Okay, so √12 minus root -3. Let's just go ahead and distribute this. Let's go 3 times √12. √12 times root -4, that's going to be √12 times 2i, because root -4 is 2i. With the next part, it would be -3 times I √3, so I can take the I out, but leave the √3. And then our last term would be negative I √3 times 2i. So I'm going to simplify all this. So we get 3 √12 plus 2i √12 minus 3i √3. And this last one has an I squared because you have an I here and an I here. So it's going to flip my sign. So this would be plus 2 √3. Okay, so let's take care of these radicals. So this is tedious. √12 is going to be 2 √3. That's a simplification because it's 2 times 2 times 3. So you can take a 2 out. So this would be 6 √3. Same thing here. We're going to take a 2 out. So this would be 4i √3. Minus 3i √3 plus 2 √3. Okay, now we just combine all these. So we'll have 8 √3 plus I √3. And if I want to write that in the form of a plus bi, it should look like that. So you have a plus bi. Okay, our next example, x squared plus 9. So let's, we're going to solve this. So normally, before we really talked about complex numbers, we would say this has no solution. And the real answer is it has no real solution. It does have an imaginary solution. So x squared equals -9. Take the square root. And x equals plus or minus, and root -9 is going to be 3i. And so the solutions to that would be plus or minus 3i. Okay, so let's look at this example. X squared plus 4x plus 5. Okay, so normally we can't factor this, right? There's no two numbers that multiply to 5 that add to positive 4. So what we do with this is use the quadratic formula. So if you can't remember that, it's negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So I'm just going to run this through the quadratic formula. So x equals negative 4 plus or minus a square root of 4 squared minus 4 times 1 times 5, all divided by 2 times 1. Okay, so we're going to have some simplification to do here. So negative 4 plus or minus square root of, so inside the square root we'll have 16 minus 20, which is negative 4. That's all over 2. Now let's do our simplification. So negative 4 over 2 is negative 2, plus or minus. The square root of negative 4 is 2i, and then we're going to divide it by the denominator of 2. So this would be I. Okay, so if you get to a quadratic where you can't factor it, you're going to use the quadratic formula.